Hi, I'm Bill Hitchcock, and I'm just going to demonstrate how we can work with some powers. In other words, if I take the number 10 and raise it to the first power, or raise it to an exponent, the first power, the second power, and so on, I just want to do a quick review on that. So, the first thing that I want you to understand is we have this identity. If you take some number, say 10, and raise it to the 0 power, that number always equals 1. That's our starting point. So what we say is we say x to the 0 equals 1, or another way of thinking of this is if we say 1 0 base x, that is always going to equal x base 10. So 1 0 base 2, for example, is 2 base 10. All right, so let me give you a quick couple examples here. If we start raising numbers to the powers, we're going to take 10, raise it to the first, 10, square it, 10, cube it. So 10 to the first just equals 10. 10 squared means 10 times 10, or 100. 1 with 2 zeros after it. 10 cubed is 10 times 10 times 10, or 1000. Another way of thinking of it is it's really 100 times 10, or 10 squared times 10 to the first. And what you do if you're multiplying, you add the exponents, you get 10 to the third, which also equals, all these equal the same number, 1000, 1000, 1000. So likewise, if I do 10 to the fourth, it's the same as taking 10 to the third plus another, or I should say times another 10 to the first. So I'd have 1000 times 10, or 10,000. It's 10 times 10 times 10 times 10, 4 times, 10 to the fourth. 10 to the fifth is 10 times 10 times 10 times 10 times 10, 5 times. So think of it as 1 with 1, 2, 3, 4, 5 zeros after it. It's 100,000. All right. Now let's go the opposite way. Suppose that I have 10 to the negative 1. 10 to the negative 1 is the same as taking 1 over 10 to the first, which equals 1 over 10, or 0.1, 1/10. 10 to the negative 2 equals 1 over 10 squared, which is equal to 1 over 10 times 10, which is 1 over 100, which equals 0.01, 1/100th. 10 to the negative 3 is going to be 1 over 10 to the third, which is 1 over 10 times 10 times 10, which is 1 over 1000, which is 0.001, 1/1000th. And we can keep on going with something like that. All right, so now that you have kind of that concept, let's think about this for a different numbered base. Take the number 2. And we want to try 2 to the 0, 2 to the first, 2 squared, 2 cubed. I'm not going to bother writing the little caret there. 2 to the fourth. Well, this is, as we said before, 2 to the 0 is 1. Any number x raised to the 0 power is 1. 2 to the first is just itself. It's 2. just like 10 to the first was 10. 2 squared equals 2 times 2, or 4. So if we just start with 2 to the 0, we multiply it by 2, we get 2. You multiply 2 by 2, you get 4. 2 to the third is 2 times 2 times 2, or 2 to the second times 2, which is going to equal 8. 4 times 2 is 8. 2 to the fourth, 2 times 2 times 2 times 2 is 8 times 2, or 2 times 2 is 4, times 2 is 8, times 2 is 16. And we have numbers like that. All right, let's try this going with negative exponents. I've got 2 to the negative 1. Just like we said, 10 to the negative 1 is 1 over 10. 2 to the negative 1 is 1 over 2 to the first, which equals 1 over 2, or in other words, 1/2. Or if you want to write it as a decimal, it's 0.5. 2 to the negative 2 is equal to 1 over 2 squared equals 1 over 4, which is 0.25. It's 1/4. 2 to the negative 3 equals 1 over 2 cubed, which equals 1 over 2 times 2 times 2, which is 1 over 8, which is equal to 0.125. And we can keep on computing out these powers of 2 to negative powers. And if you're wondering, it's like, how do I get 0.125? Well, think of it, it's 1 over 8. It's 1 divided by 8, which, writing that another way, is 1 divided by 8. 8 can't go into 1, so we write a 0, put a decimal place. 8 can go into 10, which goes in 1 time. That's 8. I get 2 remaining. I bring down a 0. 8 into 20 goes 2 times. That's 2 times 8 is 16. We do the subtraction. I'm left with 4. I bring another 0 down. 8 into 4, or 8 into 40 goes 5 times. 5 times 8 is 40. And my remainder is 0. And I can stop. There's my decimal value. All right, so let's stop here for a second, and we're going to switch over. All right, what I was going to do is try to switch over to Excel because I wanted to show you how this looks on a spreadsheet. I'll do that in the next quick video, so let me pause this one here.